Hi everyone and welcome to Chapter 8 of Exploring STEM and Coding with EDU PICO. In this part, we will learn to program light sensor to measure ambient brightness. By now, you have probably seen the APDA sensor on the EDU PICO has many benefits for your projects. There is one more feature we haven't covered yet, the light sensor. In this activity, we will learn how to measure different levels of ambient light, allowing you to create projects that respond to changes in lighting conditions. Shine light to the light sensor to increase the brightness level. Block light from entering the light sensor to decrease the brightness level. To start, we need first to enable the plotter function in Sony IDE to have a better visual on the light sensor value. Now we are ready to write the code for this activity. Line 6 to 7. These lines enable color sensing on the APDA sensor and set the color gain to 2. The color gain affects the sensitivity of the color sensors. A higher gain value makes the sensor more sensitive to changes in color or brightness. You can tune the gain to adapt with different lighting conditions. Line 10. Read the color data from the APDA sensor, which includes the red, green, blue, and clear values. The clear value represents the amount of ambient light, which can be used to estimate brightness. Line 11. This line calculates the brightness level as a percentage by dividing the clear value by the maximum possible clear value and then multiplying it by 100. This conversion is used to represent the brightness in a human-readable form. Line 12. Print the calculated brightness level to the console with 1 decimal point of precision. We have compiled a list of unique applications for light sensors that you might find intriguing. Digital cameras often have light sensors that automatically adjust the appropriate exposure for a photo. These sensors can quickly measure the ambient brightness and adjust the camera settings to capture the best possible image. Vending machines, ticketing machines, and bill validators often employ light sensor to detect the authenticity of banknotes by analyzing their optical properties and security features. Museums use light sensors to control the illumination of valuable artifacts to ensure the light levels are carefully regulated to prevent damage to the exhibits. Solar panels use light sensors to track the sun's movement, ensuring that they are always pointed at the sun to maximize energy generation. This process is called solar tracking. Well done completing part 1 of Chapter 8. In the next video, we will explore the temperature and humidity sensor. Thanks for watching and I will see you in the next video.